See the little red thing up in the corner where it says recording? Now it's recording. All right, so today we're going to talk about output stream manipulators. Output stream manipulators allow you to format your output. Right now, we don't have any control over our output. When you wanted to write your header, for example, your header file, you had to put a whole bunch of little spaces, and that was kind of a pain in the neck. So today we're going to learn some ways to handle this, to format our output. For most of these things that we're going to do, you're going to need to include a new library. And so you will include this one called IOMANIP. What does that stand for? Input Output Manipulation. So see, they name these things to make some sense here. So you'll include Input Output Manipulation. So one of them we've already seen. One output manipulator that's already available to us that we've already used. This one does not need the IO manip library. Is nline. We've already used nline. We know what that does. A new one we're going to use is called setW, which stands for set width. That will allow us to set the field to a width n and causes the next output, and only the next one, to be right justified. By default, everything in C is right justified, not left justified, which takes a little bit of a while to get used to. Everything pushes to the right, not the left. I don't know why, but that's the way they wrote it. And then we're going to use another manipulator called set precision, which will allow us to decide how many decimal points we want to be printed. All right, so here's a nice little program here. We have include IOStream. We've been using IOStream already a lot. That's for C in and C out. But here's a new one, include IO manipulator. And then using namespace std, void main, cout, set w15 name, and then set w22 address, set w23 phone. All right, so what's this line going to do? Set w does what? It saves, in this case, since this is a number 15, it's going to save 15 spaces on the screen. And then this name will be printed within that 15 spaces, but where will it be printed? Printed where? It'll be printed on the right. So the letter E will be in space number 15. The letter M will be in space number 14, 13, 12, which means there's going to be 11 blanks. And so you can see that down here, the way it prints. So the 15 says, save 15 spaces for me, but then put this in the right. So name will be pushed to the right. There will be 11 blanks. Same thing with the next one. The next one says, save 22 spaces for me, and then put the word address. So after this E right here, there's 22 spaces saved, and this S right here is in space number 22 following that E, which means we had 15 here and 22 here. This S is in space number 37 altogether. So notice again, it pushes it to the right, so it leaves blanks in front. And finally, phone. Phone gets pushed 23 more to the right, where this E is 23 spaces to the right of that S right there. So this makes it fairly easy to do something like building a table, because now on the next line I can say, all right, save 15 spaces and put 4 dashes. And so those 4 dashes will line up exactly under the word name. I don't have to count how many spaces I need and make sure I have the right number of spaces here and the right number of spaces there to make those line up. It does it for me. Same thing here, set W22. Address had 1, 2, 3, 4, 5, 6 letters, so I put 6 dashes and it lines them up right for me. So if you ever need to format your output and build a table, using this set W is the way to do it, because then you'll be guaranteed that things will be lined up. Now, they'll always be lined up on the right. A lot of times when we build tables, like if you build a table in Microsoft Word, it lines stuff up on the left. But in C, we're going to line them up on the right. Is that a big deal? I don't think so. Not really. All right, so let's look at B here. Determine the output of the following, assuming that answer is the number 33. and number is the number 7,132. So C out, set with 4, answer, set with 5, num, set with 4, the word high. So exactly what will this print? Okay, when you say ANS, do you mean it's going to print the letters ANS? It's going to print the number 33, isn't it? Yeah. So it's saying save 4 spaces and then print 33. So how many blanks are there going to be? There will be 2 blanks and then the number 33. And then it says save 5 spaces and print this number. So how many blanks are there going to be? There'll be 1 blank, 7132. And then finally, save 4 spaces but print the word high. So 2 blanks and then the word high. So that's exactly what that will print. Alright, how about the next one? Set with 2 and then print the number 33. That will just print the number 33. No blanks because there aren't enough spaces left over for blanks, are there? Set with 4, then print num. 7132. No space at all because there's no spaces left over. And then high again with no spaces. So that one's just going to slam everything right together. Not going to look very nice. All right. What about this one? 4 spaces and then 33. One space, then high. 1 space, 7132. Okay. 4. What's 4 do? 5 spaces, then high. And then no room left over, is there? Because we need 4 spaces. We're only doing 4 spaces, so 7132. What if the set W was 3?
Yeah.
So that's like the next problem. So yeah, you're thinking ahead there. So this one says set with 1, but then print answer. But answer is 2 spaces. No, I won't cut it. It'll actually still print 33. It'll print 33, but then it's going to push everything over 1. So here, the next one says save 5 spaces, so it'll still give a blank, 7132. But now your counting is off if you're trying to build a table and line stuff up, because this one used 2 spaces when you only wanted it to use 1. So in general, you want to make sure your set widths are big enough to cover your variables, otherwise you get your columns mixed up and it causes confusion.
You do multiple variables, but then let's say set with is less than sign answer, less than sign number.
Alright, so his question is, could I do C out? This is an excellent question. Set width 5. Answer num1. The answer is yes, that's valid code, but what's it going to do? It's going to save 5 spaces and print answer. So answer was the number 33. So it'll do that. And then it prints num1. This set width does not affect that num1. Set width only hits the very next thing that comes up. So it would then print num1, which was 7132. It won't put extra spaces in like you think you want it to. So if I wanted the extra spaces, I would need to put another set W5 right there, and then it would push it out 5 spaces.
Or if you don't know the length of the num1.
If you don't know how big num1 is going to be, well, then you have to take your best estimation and make your set width bigger than what you think that's going to be. So that can be a little dangerous, I agree, because you might think set width is only going to be as big as the thousands, or you might think num1 is only going to be into the thousands, and suddenly something happens that gets into the 10,000s, and maybe you didn't save enough spaces. No, the numbers will never overlap. It would push it to the right, but then your columns wouldn't line up if you had more things printed after it. Correct. Yep. Other questions? It would be a good trick question for the quiz. Let's think about that for next week. Hint, hint. I don't know. I haven't written a quiz for next week yet. All right, decimal places. So for decimal places, we use the notation cout, set precision, n. Now, this one, the cout, set precision, n, sets the number of digits outputted. And these digits can be both before and after the decimal place. And we'll see the difference here. And this will not add trailing zeros. However, if you add the line cout fixed and then cout, and I think you can use a dot like that, or I think you can use a double less than. See, there's two different notations. Cout precision n. This sets the floating precision and will add trailing zeros. All right, so the difference between those two. If I have a little example, a little program here, calling in the input-output stream, calling in the I/O manipulator, and I set f to be the number 314159. And I say set precision 5. What that's going to do is it's going to print 5 digits. And those 5 digits can be either before or after the decimal point. So that's going to print, ooh, my decimal's off here. I changed my number. That's going to print 314.16. It's going to print 5 digits starting at the beginning. So 1, 2, 3, 4, 5, and then it rounds off. It rounds up. Yeah. So it's not like it's treating it like a num and just, or like an int and just truncates it. It will round in this case. If I do set precision 9 and tell it to print f, it will print 314.159. So notice I told it to give me 9 digits, but it doesn't. It still only prints 6, because that's how many were given in the original number. Conversely, if I add this line in front, cout fixed, and then I say cout set precision n, or set precision 5, now it's going to give me 5 places after the decimal point. So that's what the difference is. When you add that cout fixed, it's now fixing the number of decimals after the decimal point. So this one would print 314.159, and then it would add 2 zeros. Because we said I want a fixed number of decimal places, and I'm telling you I want 5, so it's going to print 5 things after the decimal, so it will fill in the zeros there. Where the one up above, even though we told it, give us 9, there were only 6, it does not fill in the 0. So that's the difference between using fixed and not using fixed. Fixed determines exactly how many decimals after the decimal place you will get. Without the fixed, it's just total number of numbers. All right, so this one, when I tell it I want fixed, give me 9, it's going to print 314.159, and then it's going to add 6 zeros. Because I told it I specifically want 9 decimal places. Slide it up so you can see. All right, so what would you do if you were writing a program and the program was outputting answers and those answers were money? How would you set it up to print money? Alex?
See out fixed. Next line, see out set precision.
Exactly. I got to spell precision correctly. So if you were running a program and you wanted to print things that were money, you would typically always want exactly 2 decimal places after the decimal. So you do a cout fixed, a cout set precision 2, which would always give you 2 decimals. Now you would need to be careful on this. Maybe this is what you want, maybe it's what you don't want. But if your answer turned out to be 15.137 cents, what would this give you as an output? 15.14. So then you need to be careful and decide, do you want it to round up like that or not? When would you not want it to round up? When you're buying something. Or if you own a bank. For example, when you earn interest doesn't always come out to be exactly an even penny, you know. There's partial pennies. The bank truncates and saves those partial pennies. And they make a lot of money off of that. You'd be surprised how much money they make off partial pennies. There was a movie about that many, many, many years ago. What is it? Office Space? I don't remember. Maybe. I think that was it. And somebody, broke into the bank and learned how to take those partial pennies and have them dumped into his account and made millions of dollars off of it before he got caught. Got arrested for embezzling, unfortunately, eventually, but, the danger you can. All right, so same code as up above, but now F is the number point 0, 0, 0. How many zeros are there? 1, 2, 3, 4, 5, 6, 7 zeros. So if there are now 7 zeros and then the number 7, and you say set precision 5, it's going to give you your answer in scientific notation. Because there's too many things there for it to print. Prints in scientific notation. Even if you try doing set precision 9, it's going to give you scientific notation. How come? Because it would want to print the leading 0. It would want to print 0.0000, and again, there's too many digits there. So it will give you that in scientific notation. On the other hand, if you tell it fixed, then it does the first 5, 1, 2, 3, 4, 5, and it rounds off. So it rounds it off to what looks like the number 0 because that 7 came too much later. Conversely, if you tell it give me 9, it gives you a couple extra zeros because of how many digits you told it you wanted. Okay. Questions on that?
Is there a maximum for what the precision can
Is there a maximum for what the precision can be? Yes. Do I know what it is? No. But it would also depend on what type of variable you're using. If you're using a float variable, float only saves so many digits, and I forget right off the top of my head how many it is. I want to say 6. And if you're using double, I think double saves 9. So if you do set precision more than that, it wouldn't matter anyway. The funny thing is, though, you need to be careful about that. Sometimes if you do things that are outside the bounds of the variables, it'll give you numbers. But they might not be the right numbers, that's right. Sometimes it'll generate garbage for you. And then you don't know what the heck's going on. So be careful of that too. We will not run any programs in this course where we have to worry about more than 2 or 3 or 4 decimal places, so we won't have that issue. But if you're, doing some heavy scientific crunching, then you do have to worry about that. All right, finally for today. This is a short one. What if you want to left justify things? We talked about that we always right justify. Well, you can left justify. So to left justify, you need to call in the IO stream and the IO manip again, as always. And then you use this command. So cout dot setf ios double colon left, semicolon. So that command tells the computer, all right, everything I print now, everything I print, I'm going to want it left justified. So what would this command do if I gave cout set width 40 George Herbert? What would that print? Correct.
Does that apply to all of the following statements, or just this next cout statement?
This one right here applies to every cout statement from now on until you tell it I no longer want to left justify. So this one goes forever. So what this is going to print, this is going to print George Herbert. And it'll print it on the left, because we said left. And then that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 characters, I think, in my name. But we told it save 40. So what's it going to do? It's going to save 24 blanks. All right, and now I don't have enough space on my paper, but we'll see how that goes. And then the very next line says, all right, I'm done left justifying stuff. Now I want to right justify stuff. And then we say, save 40 blanks, and then print the words if statements. So what's that going to do? It's going to go all the way to the right, and it's going to print if statements, and then it's going to leave a bunch of blanks in front of it, isn't it? So it's going to leave more blanks, the right number. I'm not going to count them. And it's going to print if statements. All right, so why did I use 40 and 40? A line in C, in that output box that you get, can be 80 characters wide. So this will put George Herbert all the way to the left, and then the 40 spaces, and then 40 more spaces is 80 spaces. This will be all the way to the right of the page that it can print. So instead of having to count how many spaces I want, there's a way to have your name be perfectly on the left and your program name be perfectly on the right. Good. No? Good. I do not think there's an iOS center, but I will look that up. We'll try it. I'll go to my office and try it after class and find out. Now, unfortunately, it gets to be a little bit of a pain in the neck. And again, this is the way C is programmed, and I'm not sure why this happens, but it does. I can tell it left justify, and then I can tell it right justify. But if I try to tell it to left justify again, it won't work for some reason. I don't know. My guess is because by default everything is right justified. So I have to tell it cout unset the right justify, and then again I can tell it now left justify for me. So it's weird. I can tell it left justify, and I can tell it right justify without telling it you have to unset the left. So it will go from left to right, no problems. It will not go right to left. And I honestly don't know why that is, but it is. And if you leave this line out right here, if you leave that out, go ahead and try it, because I already did. Even though you put this cout, telling it to left justify, this due date will still be right justified. It will be. That's whoever built C, that's the way they built it. Makes it kind of a pain in the neck, so you got to add that extra line each time in order to be able to go back to the left. Questions on that? So, here's a new way, if you wanted to, that you could write your header, And then you know that everything's going to line up perfectly on the left, everything's going to line up perfectly on the right. You don't have to count spaces to make stuff line up if you don't want to. And I still want the asterisks below, above and below. And in a few days, when we get to looping, we'll talk about how what's an easy way to write a little loop to print 80 asterisks above and 80 asterisks below, without having to count 1, 2, 3, 4, 80.
That's kind of related. Is there any built-in function method, or whatever you want to call it, that just does that automatically, or do you have to make it work?
I don't think there's anything automatic that says, I want you to print so many asterisks or so many of any character across the screen. I think you have to do it as a loop. Or count and push the asterisk button 80 times and make sure you have exactly 80. And then, of course, you take this output and you copy it to Word, and the number of spaces in a Word file is different, so then it messes all your spacing up anyway, which is a pain in the neck, which you've already seen. So that's unfortunate that the Word spacing isn't the same as the spacing as Visual Studio. I mean, they're both Microsoft products. You'd think they could make them the same, but they chose not to. Other questions, comments, concerns? All right, so this, personally, when I write programs, I don't use this left and right a lot. I use it occasionally. I do use the set width a lot. Like I said, especially when I'm building tables and I want stuff to line up, the set width is very useful for that. Again, just keep in mind that things are going to line up on the right, so it might look a little funny to you. That's okay. And then the set precision. You know, quite often when you're writing programs, you do want things with a specific number of decimal places, so that you'll probably use several times throughout the semester. Questions? The first part we went over? Okay, so let me give you another example. Let's do cout, set width 6, and then I'm going to print the word cat. You do like cats, good. Oops, I forgot the W on set width. Set width 6. And then we'll do another set width, nice little number, 12. I was hoping for smaller than that, but that's okay. Dog. You got cats, you got dogs, right? They go together. Okay, so what this does right here is it says, save me 6 spaces. So it's going to save 6 spaces. 1, 2, 3, 4, 5, 6. And then take this word cat and write it, but put it all the way to the right. So this T goes in the last spot right there. And then the A would be before it, and the C would be before that. And then this one says, all right, now take 12 more dashes. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then dog goes in that space, but again, dog goes to the right, so the G goes in the very last one. And then D and O come before it. So that's exactly what that line would print. So you'd have 3 blanks before cat, and then 9 blanks before dog.
So it basically defines your input space, and then says this is the space you have to work with, and taking in the input from this side.
Correct. That's exactly what it does. It says, this is the space, you have 6 spaces, and put this word on the right of that 6 spaces. Always on the right. Unless, of course, we tell it, set it to the left, and then you could set everything to the left also. So you could put that command, if you want your tables left justified, at the top, you could put a cout, tell it to always go to the left. Listen. Yes, it would not matter what was inside these quotes. So if I had cout set width 6, cat with an exclamation mark, cat, then it would still save 6 spaces, and now the exclamation mark would be all the way to the right, and then the word cat would come before that. So that would save 2 blanks, and write cat with an exclamation. It wouldn't matter what's inside those brackets, what's inside those parentheses, the last thing always goes all the way to the right. Other questions?
How come the things on Part B, how come one of the spaces affected the next one?
Say that again.
The 33 on Part B, side, the 33 is a lot over on 4.
Oh, because we did a bad thing. We said only do set width once, 1. So we said only save 1 space. But then unfortunately the thing we tried to print was more than 1 space. So if you do that, it's going to fill. It's not going to just chop it off. It will fill it, but it will make it print in 2 spaces because it takes 2 spaces. And then your next set width will start from where that one ended. So it won't put this, that number 2 right there, it won't be in the column where you thought it was going to be. It's going to be pushed over 1 space because you didn't save enough spaces over here. So again, be careful when you're outputting stuff. You want to try to think ahead and think about how many spaces it's going to take, and always try to make sure your set width is bigger than, or at least equal to, the number of spaces you think it's going to take. Which again can be tricky with numbers, because sometimes numbers can get bigger than you thought they were going to be, and you'll see it when you run your program, and now suddenly your stuff has jumped to the right and your table doesn't line up anymore. Other questions?